Okay, video 2 here for Unit 6, Lesson 2. So again, we're doing number 2 here, which was on arc measure, which was the last video. And now we're going to talk about arc length, which is this video. Okay, so let's get right into the definition of what arc length is. So arc length. So arc length is a fraction of a circle's circumference. And again, you might need a refresher on what circumference is. Circumference is just the perimeter of a circle. And for those who need a refresher on perimeter, perimeter is just the distance around a figure. So when we did arc measure in the last video, we were talking about how many degrees out of the circle the arc was. Well, now we're talking about the actual arc length. So if I were to measure it with a ruler, right, and again, it's a curved surface, but if I were to like unroll the circle, how long it is, right? So again, when I have a circle, right, here is a center, here's one radii, here's a second radii, you create that arc, right? The length of the arc is this right here, this length from end of radius to end of radius. And again, it's not in degrees, it's a length in units like feet, centimeters, whatever the units of the radius is. So again, you will have an angle measure, essential angle measure, which will have an arc measure. So you just use the arc measure, right? So there are two ways to remember the formula for arc length. The first way, if we tie it back into Unit 4, is using proportions. If we take the arc length of a circle, or a piece of a circle, and divide it by the circumference of the circle. So this is that fraction of the circumference. This ratio, this fraction will equal the arc measure out of 360 degrees. This idea is our idea of a proportion, right? And that's what Unit 4 was all about, was proportions when it came to similarity in right triangles, in trigonometry. Well, here we're doing the same thing. It's a proportion. The arc length of the circumference is the arc measure out of 360. Now, in terms of letters and symbols, so the arc length is S. So S over circumference is 2 pi r, 2 pi times the radius, equals the arc measure n over 360. So this is the formula using a proportion. The second way, and again, I don't care which way you think about it, if you want to have it solved for the arc length, you're just going to take the fraction of the measure of the arc out of 360 and multiply it by the circumference. And this can be used as well. I think that I will use this formula more often just because I like how it ties in, but I will do the first example both ways. Okay, so let's take a look at an example to see if we can find arc length together. Okay, so this is example 1. All right, so we're going to find the length of, and we're looking for the length of arc RT. So in this picture, I have a center of S. I have 2 radii of 16. I have R here and T here. Okay, so I have a central angle of 54 degrees. All right, so here's my setup, right? So to find the arc length, I would like to find the distance out here, right? So to find the arc length, I have to take the circumference, right? So the arc length out of the circumference equals the arc measure out of 360. Now in this picture, we have our radius at 16. So the 16 is our R. This 54 is also the arc measure. So that is our N value. So we do S for our arc length, and your radius is 16, equals N, which is our arc measure of 54, over 360. And now we're going to solve this just like we did our proportions. We're going to cross multiply. So we'll do 360 times S equals, when I multiply the 2, the 16, and the 54, I will not multiply out pi right away. I'll just do 2 times 16 times 54 in my calculator. So I'll do 2 times 16 times 54. That's 1728 pi. And then I'll take this and divide both sides by 360. The 360s cancel, S equals, and now I will do 1728 times pi divided by 360. And that gives me 15.07, which would round to 15.1, and that's in units. Okay, now let me show you the other way. So the other way is, if I use the formula, so S equals N over 360 times 2 pi R. So S equals, your N is 54 over 360 times 2 pi times 16. And you're just typing it all in at once. So we do 54 divided by 360 times 2 pi times 16. And again, your arc length is 15.07, which again is 15.1 units. So I don't care what you do. I think that this formula, I like its proportionality about it, and I think the state test likes that too. But it's up to you. Okay, second and last example of this video, so example 2. So now we need to find the measure of angle SRT. So I'm going to give you this picture. In this picture, we have a center R. We have a radius out to S. This is the length of 12. We have a radius out to T. That's a length of 12. And in this case, they give us that the length, so the length of arc ST equals 8 pi. So they're telling us that this arc length right here, that this right there, is 8 pi. And we need to find the angle measure there. Okay? All right, so let's remember that the N value, which is the arc measure, is equal to the angle measure. So in our formula, S over 2 pi R equals N over 360. This N is also the measure of angle SRT. So if we find N, we have the angle measure, because again, the central angle equals the arc measure. So let's fill in what we know. So this 8 pi is S. So 8 pi over 2 pi, your radius is 12, equals N over 360. Now the one thing I really like about this, and some kids forget this, is because their arc length is in terms of pi, that 8 pi, look at this fraction right here. Do you see how we can just cancel the pi, top and bottom? That's a beautiful thing, right? It's really, really good. Okay, so now what is N being multiplied with? Cross multiply. N's being multiplied with 2 times 12. 2 times 12 is 24N. Then we do 8 times 360 the other way. 8 times 360 gives us 2880. And then we divide both sides by 24. And 2880 divided by 24 gives us an N value of 120, and that is in degrees. So the arc measure is 120, and so is that angle measure. So the measure of the angle that we're looking for is 120 degrees. All right, good luck with this arc length material.